In this video, we're going to be going over how to use U-substitution to solve indefinite integrals. So we're going to do this by solving several different examples of all different types of integrals. And so if you want to skip to a specific type that's closer to one that you're having trouble with, these will all be in the timestamps below, so feel free to jump forward. Otherwise, we're just going to get started and solve these integrals. So for the first integral, we have the integral of 3 times 3x plus 6 raised to the fifth. And so for this, we need to identify what we want to use as our U substitution. And so for this, we're going to let U equal everything in parentheses, 3x plus 6. And then we need to figure out our du. So to do this, we need to take the derivative of U with respect to x. And this is going to just give us 3. And so then we can solve for dx. So if we multiply by dx, divide by 3, this is going to be du divided by 3. And so now we go back to our integral, and everywhere we see 3x plus 6, we replace it with u, and we replace our dx with du over 3. So if we do that, we get the integral of 3 times u to the fifth, and then our dx is going to be du over 3. And so here our 3's are going to cancel out, and this becomes the integral of u to the fifth times du. And here we just use our rules for integral. So we're going to take our exponent and raise it by 1 and then divide by that exponent. And then we need to add our constant plus c. And now we need to plug our value of u back in. So if we do that, we get 3x plus 6, all raised to the 6th power, divided by 6. So if you wanted to simplify this even further, you could do that by factoring out a 3 from each of these 3x plus 6 terms. And if you do that, if you do it 6 times, you end up getting 3 raised to the 6th times x plus 2, since you factored out the 3, over 6, but you can write 6 as 2 times 3. So one of these 3's are going to cancel, and you're left with, I'll write it over here, you're left with 3 to the fifth, which is 243, times x plus 2 raised to the 6th, all over 2. So one of these cancels, and then plus c. So for our next integral, we have 2x times x squared plus 5, all raised to the minus 4th. And so for this one, our u, again, is going to be everything in parentheses. So this is often a good first place to start for u substitution. So u equals x squared plus 5. So we take the derivative of u with respect to x, and we get 2x. So this means our du is going to equal 2x dx. And so at this point, du equals 2x dx, so we notice 2x dx, exactly that is in our integral, and so everywhere we see 2x dx, we can just replace it with du. And so if we do that, then x squared plus 5, that's our u, so it's u raised to the minus 4th now, and 2x dx is just du. So now we're just ready to integrate, and if we do this, we need to raise u, we need to increase the exponent, so minus 4 will go to minus 3, and then we need to divide by that new exponent, include our constant of integration, and now we just need to plug in our u, so this is going to be x squared plus 5, all raised to the minus 3rd, over minus 3 plus c, or we can bring this down, so this is going to be minus 1 over 3 x squared plus 5 cubed, and then plus our constant of integration. So for our next integral, we have the integral of 3x plus 2 all times 3x squared plus 4x raised to the 4th power. And so for our u, we're going to choose the second set of parentheses, 3x squared plus 4x. And you're going to see why we choose this one rather than what's in the first set of parentheses. So if we find our du, at this point, I'm just going to leave my dx off because I know I'm just going to multiply it. But we're really taking the derivative of u with respect to x. So this is going to be 6x plus 4. And then our dx would normally be on bottom, but instead of writing it there, I'm going to start just writing it on the term to the right. Now if we look, we can factor out a factor of 2 from everything over here, and this becomes 2 times 3x plus 2 times dx. And we have 3x plus 2 dx in our integral. Okay, so really we can divide both sides by 2, and this is going to go away. And so everywhere we see 3x plus 2 dx, we can just replace it with du over 2. Okay, so if we do that, first I'll start with my 3x squared plus 4x, so that's going to be u raised to the 4th power, and then we'll replace the 3x plus 2 dx with du over 2, and that's just going to be 1/2 the integral of u to the 4th du, and if we use our rule, we get 1/2. We need to increase our exponent to 5 and then divide by that exponent plus our constant of integration. And then we'll plug back in, so we get now 1/10. And then our u is 3x squared plus 4x, and that's raised to the 5th power plus c. And then if you wanted, you could simplify this even more. So like we did in the first problem, you could factor out an x from both terms in parentheses, and you would do it 5 times. So you could write this as x to the 5th times 3x plus 4 all to the 5th all over 10. And that would be another way of writing this. Our next integral, we have the integral of x times sine of 2x squared dx. So for this integral, our u is going to be the argument inside the sine function. Okay, so then it becomes u equals 2x squared, so our du is going to equal 4x dx. And if you look, we have an x dx in our integral, and so that's what we want to replace. So I'll write this as x dx is du over 4, so I'll divide both sides by 4. And now we have everything we need to go in and substitute. So sine of 2x squared is going to become sine of u, and x dx we're going to replace with du over 4. And now this becomes 1/4 the integral of sine u du. Okay, and the integral of sine is just minus cosine. So we get 1 over 4 times minus cosine of u plus our constant of integration, and now we can plug back in, so we get minus cosine of 2x squared all over 4 plus c. Next integral, we have the integral of secant of 2t times tangent of 2t dt. And so for this one, we're going to let u equal 2t. So our du is going to just be 2 dt. So this one I'm going to go ahead and solve for dt. So dt is du over 2. Okay, and now we'll go in and start our substitution. So this just becomes our dt is going to be replaced with du over 2. So I'll just bring out that 1/2. And this is going to be secant of u times tangent of u du. So now we can replace these trig functions in terms of sines and cosines, and that's going to make our integration a little bit easier. Okay, so anytime you have something other than sine or cosine, you should think, would this simplify if I wrote it in terms of sines and cosines? So secant of u is just 1 over cosine, and then tangent is sine over cosine, okay, times du. So this gives us 1/2 the integral of sine u over cosine squared u. Okay, and at this point, it doesn't look like we made things any easier, so we're actually going to do another substitution. So now we're going to let v equal cosine of u. And so now when we find dv, because we're taking the derivative of cosine is minus sine, so now we have our sine showing up. So now we can do another substitution. So we have 1/2 the integral of sine u du, we're going to replace with minus dv. Okay, so we'll just move this minus sign to the other side. Okay, and then our 1 over cosine squared is just going to be 1 over v squared now. And so if we do that integral, we get minus 1/2 the integral of v to the minus 2 dv, not du. And now we know how to evaluate this integral. So this is minus 1/2. And then again, we just increase the exponent. So minus 2 goes to minus 1. We divide by that exponent, that new exponent, at our constant of integration. And now we just need to rewrite this. So this is going to be our minus and minus will cancel out. So this will be 1 over 2v. It'll come down since it's a negative exponent, plus c. And we need to go back and plug in our v. So this would be 1 over 2 cosine of u plus c. And now we need to do one final substitution. So before I do that, I'm going to rewrite 1 over cosine as just secant. And then I'm going to replace u with 2t. And that's going to be over 2 plus c. For our next integral, we have the integral of square root of x times sine squared of x to the 3/2 power minus 1. Okay, so this one's really involved, but a good place to start again is take our u to be the argument of our sine function. So we're going to try that. X equals 3/2 minus 1. And so our du, we're going to bring down our exponent, so 3/2, and then we're going to decrease it, so 1/2 dx. And so this is going to give us square root of x dx. And then I'm going to move my 3 over 2 to the other side, so it's going to equal 2 du over 3. Okay, so now everywhere I see square root of x dx, I can replace it with 2/3 du. Okay, so now we're ready to do our substitution. So if we do that, sine squared of this argument is going to become sine squared of u, and then square root of x dx will become 2 du over 3. So this is 2/3 the integral of sine squared u du. And now we have to use a little bit of trig. So we need to rewrite this using an identity from trig. So if we do that, this is 2/3 times the integral of sine squared u. We're going to replace with 1/2 minus 1/2 cosine of 2u du. And now when we integrate, we need to distribute our du, and this is really going to be two integrals. So our 2/3 times 1/2, so this first term, the 2's are going to cancel, and we're going to get 1/3 of the integral of du, which is just u. And then again, we have 2/3 times 1/2, so the half, the 2 from the 2/3 and the half are going to cancel, and we get a 1/3 out front. And then we have the integral of cosine 2u du. And so that's just going to give us sine of 2u over 2. Okay, and then plus our constant of integration. So the integral of cosine is just sine, and if we have a number or coefficient in front of our variable in the argument of the sine or cosine function, it just comes down. Okay, so you can take the derivative of this just to check it really quick. And now we just need to plug in. So we have 1/3 of u, which is x to the 3/2 minus 1, minus our third and our half are going to multiply, and we're going to get 1/6 sine of 2u. So sine of 2 times x to the 3/2 minus 2, and then plus our constant of integration. For next integral, we have the integral of dx over the square root of x plus 8. So we're going to let our u be the argument of our square root of our radical. So u is going to equal 5x plus 8. So our du will be 5 dx, or dx is du over 5. Okay, so now we're ready to substitute. So our 1 over this square root will turn into 1 over the square root of u. And then our dx will become du over 5. So we can rewrite this. We can bring out our 1/5 out front. and this is the integral. We're going to bring our square root of u to the top, so it's going to be u to the minus 1/2 power du. And now we can just use our rules. So this is 1/5. So this is going to become u to the 1/2 divided by 1/2, okay, plus our constant of integration. So this is going to equal, dividing by 1/2 is the same thing as multiplying by 2, so this is like 2/5. Our u is 5x plus 8. That's to the 1/2 power, so we could write that as a square root. So if I do that, that's just 2/5 square root of 5x plus 8 plus c. And now really quick, I want to show you that you can sometimes use two different substitutions and get the same answer, and sometimes it's easier and sometimes it's not. So you still want to get good at choosing the easier substitution, but sometimes it doesn't matter. So if we wanted to do this again, we could do u equals the square root of 5x plus 8. And then if we do that, our du is the derivative of this, so this is a little bit more involved, but this is 5x plus 8 to the 1/2 power. So when we take the derivative, we'll get a 1/2 out front times 5x plus 8, and then we need to decrease the power by 1, and then multiply by the derivative of the inside, which is 5, and then we can't forget our dx. So this gives us dx over the square root of 5x plus 8 is equal to 2/5 du. If I just move that over. And now if we substitute, we can see that our entire integral, dx over square root of 5x plus 8, is just our 2/5 du. So this is 2 over 5 du, which is just 2/5 times u plus c. And then if we substitute, we get 2/5 square root of 5x plus 8 plus c. And so you can see there are some trade-offs. If you do the second substitution, then we have to do a derivative with this radical, and we have to take a chain rule. But then when it gets to the substitution part, it's really easy. And doing our integral is much easier. If you do it the other way, then taking your derivatives of u is really easy, but then when you get to integrating, you're integrating something with a fractional power, and so that's where it's more complicated there. So you can kind of choose which way you want to do it. In the next integral, we have the square root of 3 minus 2x dx. So our u, as usual, we're going to start with the argument of our radical, so 3 minus 2x. And so our du will be the derivative, or minus 2 dx. And so we'll write dx is equal to minus du over 2, just by moving that over. And now we're ready to substitute. So this is going to become the square root of u, and then dx will be minus du over 2. And we can write this as minus 1/2 the integral of u to the 1/2 power du. And now we can use our rules. So this is minus 1/2. And then u is going to go increase to the 3/2 power. And we're going to divide by 3 over 2, but that just means the same thing as multiplying by 2 over 3, or the reciprocal. So I'm going to write it like that, and I'm going to start doing that because it's a little bit easier. You can just kind of flip your exponent and multiply by it rather than dividing by a fraction. And so if we simplify, our 2's are going to cancel, and we get minus 1 over 3 u to the 3/2 power plus c. And if we plug in, we get minus 3 minus 2x to the 3/2 all over 3 plus c. Our next integral, we have 1 over the square root of x times 1 plus the square root of x squared. So we'll let our u equal 1 plus the square root of x. And so to make our derivative easier, this is just 1 plus x to the 1/2. So now our du is just the derivative of this, or 1/2 x to the minus 1/2 times dx, or our dx over square root of x is just going to equal 2 du. Okay, so we can see I just moved my x to the minus 1/2 to the bottom and wrote it as a square root. And then we can see that that shows up in our integral itself. Okay, and so that is the reason why we chose this to be our U-substitution. So you'll start to see that when we take the derivative of whatever we substitute in as u, we want that to show up in our integral. So in this case, we noticed that the derivative of our u would have 1 over the square root of x in it. And even if you didn't notice that at first, you could try it and see what happened. But now it's going to make it where this goes away. And so we get 1 over 1 plus the square root of x squared. Well, that's just u squared. And then the dx over square root of x is just going to be 2 du. So now our 2 can come out. And this is going to be u to the minus 2 du. And we can use our rules. So 2 times, we're going to increase this. So it's going to go to the minus first power. And then we'll bring down a minus 1. So that'll just be a minus 1 out front. So we're going to write this as minus u to the minus 1 plus c. And then we'll plug in our u again. So this is minus 2 times 1 plus square root of x, all raised to the minus first power. And so that's just going to come down to the bottom. So minus 2 over 1 plus square root of x plus c. Next integral, we have 3x times the square root of 7 minus 3x squared. So here u will equal the argument of our radical, so 7 minus 3x squared. And so you can kind of guess, when we take the derivative of this, we're going to get something times x. And so that something is going to take care of this x dx. Okay, so as we go through this, start seeing why we pick u, and see if you can't pick out the derivative and see that it's in the integral itself, so that it goes away when we substitute. So du is going to equal minus 6x dx, or we can solve this for x dx, since we see that's what is in our integral, and this will be x dx equals minus du over 6. So now when we do our substitution, we have 3 times the square root of our u, so square root of u, or maybe we go ahead and write that as u to the 1/2, and then x dx just gets replaced with minus du over 6. If we write that, our 3 over 6 will reduce to 1/2. We'll bring our minus sign out front, and this is the integral of u to the 1/2 du. So now we're ready to use our rules. So I'll write this as minus 1/2, and then we'll increase our exponent to 3/2 and divide by that, but that's the same as multiplying by 2/3. Add our constant, and then we just need to plug in. So our 2's here are going to cancel, and we'll get minus 7 minus 3x squared raised to the 3/2 power all over 3 plus c. Our next integral, assigned to the 5th power of x over 3 times cosine of x over 3 dx. So here, we're going to let u equal sine of x plus x over 3. And so you can already see that when we take the derivative of this, we're going to get a cosine, and that's going to take care of this cosine term. Okay, so as we go through this, hopefully you get better at seeing this. So the derivative of sine is just cosine. And then we need to use the chain rule and take the derivative of the inside. So we're going to get a 1 over 3 that comes out times dx. And so we can see there's a cosine of x over 3 dx in our integral. So cosine of x over 3 dx will equal 3 du. So now if we substitute, we get the integral of u to the 5th, and then our cosine dx will get replaced with 3 du. And so this is 3 times the integral of u to the 5th du. And this is 3 u raised to the 6 divided by 6 plus c. And if we plug in, our 3 over 6 will go to 1/2. And we get sine to the 6th power of x over 3 plus c. Our next integral is x squared times x cubed over 18 minus 1, all raised to the 5th power. And so we're going to let our u equal everything in parentheses. So x cubed over 18 minus 1, so I really didn't need that parentheses. And so our du, take the derivative of this, we're going to get 3x squared over 18 times dx, and this is going to just reduce to x squared over 6 dx. And so we can see we have an x squared dx in our integral. So if we solve for that, x squared dx will equal 6 du. And so now if we substitute, everything in parentheses is going to become u raised to the 5th power, and then x squared dx will be replaced with 6 du. So this becomes 6 times the integral of u to the 5th du, or 6 times u to the 6th divided by 6 plus c. Our 6's are going to cancel, and we just get x cubed over 18, not plus, but minus 1, raised to the 6th power plus c. Our next integral is x over the square root of 1 plus x. So our u is going to be 1 plus x, the argument of our radical, and then our du will just be dx. Okay, so this one is going to be a little bit different. If you notice, when we take our derivative, it's not going to get rid of this x that is on top. So if we started to substitute, we could write our u on bottom. We could write this as square root of u, but what do we do with this x? Well, there's an x right here, so we can just solve this, and we get x is equal to u minus 1. So now everywhere we see x, we just replace it with u minus 1. If we do that, we get u minus 1 over the square root of u, and then our dx just gets replaced with du. And so now we can do this integral. So this is a fraction, so we can break it up into two pieces. So this is going to be u over the square root of u, so that's going to be u, we'll write it u to the 2 over 2, so that's just u to the 1st power, divided by u to the 1/2, and minus the integral of u to the minus 1/2 du, and I forgot my du over here. And so now when you have exponents in a fraction, you subtract. So 2/2 over 1/2, if we subtract those, that's just the integral of u to the 1/2 minus the integral of u to the minus 1/2. Okay, so if we do this, then this just becomes u to the 3/2, and then multiply by 2/3, minus, we're going to increase this one as well, and this is going to go from minus 1/2 to plus 1/2, and then dividing by 1/2, that's the same as multiplying by 2, plus c, and then if we plug in for our u again, we get 2/3, u to the 3/2 is 1 plus x to the 3/2, minus 2 times 1 plus x, or this is to the 1/2, so we'll just write it as a square root. So 1 plus x square root plus c. Our next integral is the square root of x cubed minus 3 all over x to the 11th. So before we do this, and this is a common step, even when you're using U-substitution, your integral may not be ready to substitute right away. So for this, we want to simplify it a bit. And so to do that, we want to do something with these exponents. So this is going to be the integral of the square root of x cubed minus 3, but we want to rewrite x to the 11th. So one, we want to pull out an x cubed if we can, and that's going to help simplify everything in the denominator. But what that leaves over is x to the 8th, but we can write x to the 8th as x to the 4th, all raised, or all squared. Okay, so all raised to the 2nd power, and that's going to allow us to bring it out of this square root. Okay, and then we get our dx. And so if we do that, we get the integral of, again, the square root of x to the 4th squared. The square root and the square are going to cancel each other, and our x to the 4th will come out. And then we're left with the square root of x cubed minus 3 all over x cubed. Okay, so now we can reduce this just a little bit more, and we're going to get the integral of 1 over x to the 4th times the square root. We're going to separate this fraction, so x cubed over x cubed, that's just 1, and then minus 3 over x cubed, that's what's left, times dx. And now we're ready to do our u-substitution. So again, we're going to let our u be the argument of our radical. So u equals 1 minus 3 over x cubed, and our du, so maybe I'll write this in a way that makes it easier to take the derivative, so 1 minus 3 x to the minus 3. So our derivative is going to be minus 3, then we'll bring down our exponent, minus 3 x to the minus 4 times dx. Or this is minus and minus are going to cancel, 9x to the minus 4 dx. Or if you notice, this x to the minus 4, that's just 1 over x to the 4th, which shows up in our integral. So if I solve for that, I get 1 over x to the 4th dx. Now I'll divide by 9 and get du over 9. So now everywhere we see this in our integral, we can just replace it with du over 9. So now we're ready to do our substitution. So this is going to be the integral of the square root of u. Okay, so we'll start with that. And then our 1 over x to the 4th dx will become du over 9. And so this we can just write as 1/9 the integral of u to the 1/2 du. And now we can use our rules. So 1 over 9. And then this is going to be u to the 3/2 times 2/3 plus c. And if we substitute back in, first we need to multiply. We get 2 over 27. And our u will become, what is our u? 1 minus 3 over x cubed, all raised to the 3/2 power, plus c. Our next integral is the integral of x plus 1 squared times 1 minus x raised to the 5th. So for this one, we're going to let our u equal 1 minus x. And so our du is going to equal minus dx. And now again, you're going to notice we have 1 minus x in our integral, but we don't have anything to take care of the x that shows up in this first term. So in order to deal with that, we're going to solve for x from our u. So to do that, we'll just move x to the other side, make it positive, and subtract our u, and get x equals 1 minus u. Okay, so now we have everything we need to substitute. So this becomes the integral of, if we replace x with 1 minus u, then this is going to be 1 minus u plus 1. So we get 1 and 1 is 2, so positive 2. We have two positive 1s. And then minus u, and that is squared. And then everything in this next term is our u raised to the 5th power. So I don't need to put that in parentheses, u to the 5th. And dx is just minus du. So now we want to expand this out, and then we can distribute and use our rules of integration. So if we do this, we get, we'll bring our minus sign out, we get minus the integral of 2 and 2 will be 4, and then we get minus 4u, and then minus u and minus u will be plus u squared, all times u to the 5th du. Okay, so I just expanded that out. And now I can distribute my u to the 5th to each term and do each of those integrals. So I'm going to get minus my 4 out front, the integral of u to the 5th du, plus another 4, so minus and minus will be plus 4 times the integral of u times u to the 5th, which is u to the 6th du, and then minus u squared times u to the 5th will be the integral of u to the 7th. And now I can just do each of these one at a time. So this will be minus 4 times, this is going to increase to u to the 6th divided by 6, plus 4 times u to the 7th over 7, minus u to the 8th over 8 plus our constant of integration. And now we can just simplify and plug in. So we get our minus sign, 4 over 6 becomes 2/3, and our u will be 1 minus x to the 6th plus 4 over 7, 1 minus x to the 7th, minus 1 over 8, 1 minus x to the 8th, plus c. For our next integral, we have the integral of cosine of square root of x divided by the square root of x times sine squared of the square root of x. So it's a mouthful. So our u will be sine of the square root of x. And so hopefully you can see this is going to take care of the sine on bottom, and then when we take a derivative, that's going to take care of the cosine on top. So if we take the derivative of this, we get cosine of square root of x times the derivative of the inside using the chain rule. So that'll be 1/2 x to the minus 1/2 times dx, or du will be cosine square root of x divided by 2 times x to the minus 1/2. Well, that just comes to the bottom, and it's square root of x. Okay, so that's actually going to take care of the cosine of square root of x on top and the square root of x on bottom. So I'm just going to multiply by 2 on both sides, and so this can become 2 du, and then I'll get rid of the 2 there. So now I can just replace this when I see it in my integral. And so cosine of square root of x over square root of x dx, that's just going to be 2 du, and 1 over sine squared will become 1 over u squared. Okay, so now our 2 is going to come out front, and we get the integral of u to the minus 2 du, which is going to be 2 times, we'll increase the exponent to minus 1, and the minus 1 comes down, so that's just a minus sign, plus c, and then if we plug in, we get minus 2, and then our u is going to go to the bottom since it's a negative exponent, and that is sine of the square root of x, all plus c. For the next integral, we have the integral of x plus 5 times x minus 5 raised to the 1/3 power. So we're going to let our u equal x to the minus 5th, and our du will just be dx. Okay, and again, we can already see we need to deal with this x and the term to the left. So I'll go to my u equation and solve for x. So I'll just add 5 to both sides, and this will be x equals u plus 5. And so now I can substitute. So x equals u plus 5, so we get u plus 5 plus 5, so that will be u plus 10. And then x to the minus 5, that's just u raised to the 1/3 power, all times dx, which is just going to become du. And so now we can distribute this. And if we do that, we get u times u to the 1/3, so we just add those exponents. So 1 plus 1/3 is u to the 4/3 du. And then we'll get another integral. So I'll bring my 10 out front. And this is just u to the 1/3. So now if we use our rules, we get u, we need to increase this by 1. So 1 will be 3 over 3, so this goes to 7 over 3. And then if we divide by 7 over 3, that's the same as multiplying by 3 over 7. So we get that plus 10, and u to the 1/3 will go to u to the 4/3. And again, dividing by 4/3 is the same as multiplying by 3 over 4 plus c. And then we just need to plug in. So we get 3 times x minus 5 to the 7/3 power over 7 plus 10 times 3 is 30 divided by 4. We can reduce 30 over 4 to 15 over 2. And then our u will be x minus 5 to the 4/3 power plus c. Our next integral is x over 2x minus 1 raised to the 2/3 power. And so our u will equal 2x minus 1. okay, the argument in our parentheses, or of this radical. So our du will just be 2 dx, or dx will be du over 2. Okay, and again, we need to deal with this x on top, so I'm going to take my u equation, solve it for x. Okay, so I'm going to add 1, get u plus 1, then I need to divide by 2. So u plus 1 over 2. And now I can substitute. So I'll start by substituting for x. That's just going to be u plus 1 over 2. And then my 1 over 2x minus 1 to the 2/3 will just become 1 over u to the 2/3. And then dx will be du over 2. Okay, so now I'm going to simplify a bit before I start integrating. So my 2/2 are going to come out front. This is going to be 1/4 the integral of u plus 1 over u to the 2/3 times du. And so I can break this up into two different integrals. And so I'll get 1/4 of u over u to the 2/3. Okay, and that's going to give me, we're going to subtract, so that will be u to the 1/3 du. Okay, so u to the 3/3 minus 2/3 is u to the 1/3. And then plus this 4th is multiplying the other term as well. So this is just 1 over u to the 2/3, which will bring that to the top and make it u to the minus 2/3 times du. And now we can integrate. So we get 1/4. We're going to increase our exponent to 4/3, so add 3/3 or 1, and then that's multiplying by 3 over 4, and then plus 1/4. Our u will be raised, we'll increase it by 3 over 3, so it'll go from minus 2/3 to 1/3, and then dividing by 1/3 is the same as multiplying by 3, and we'll add our plus c. And now if we simplify, we get 3 over 16, since that's 4 times 4. Our u is 2x minus 1 raised to the 4/3 power plus 3 over 4 times u 2x minus 1 raised to the 1/3 power plus c. Next integral is cosine x times e raised to the sine x. So here you can already see if we let our u be the argument of our exponential, or sine x, then when we take the derivative, it's going to take care of that cosine. So when we do du, we get cosine x dx. So now we can substitute, and this takes an integral that would otherwise look kind of scary and make it look really simple. So e to the sine x will just be e to the u, and cosine x dx will just become du. And so when we integrate exponential, we just get that same exponential back plus our constant. And when we plug in, we get e raised to the sine x plus c. Our next integral is the natural log of the square root of x divided by x. So this one can be made a little bit simpler if we simplify a bit. So if we rewrite this as the natural log of x to the 1/2, which we typically want to do as a first step anyway, write our radicals to fractional exponents, then we notice we can use the properties of logs to bring this 1/2 out front. So this becomes 1/2 the integral of the natural log of x divided by x. Okay, so anytime you have the natural log of x to some number n, this is equal to, well, we can bring that n in front and write it as n natural log of x. And so we just brought this 1/2 out front using that property of logs. So now we can do our U-substitution by letting u equal the natural log of x. And so du will equal the derivative of natural log, which is just 1 over x. So make sure you remember your derivative rules for natural logs. And then if we substitute, we just get 1/2. The integral of natural log of x is just u, and 1 over x dx is just du. So this is as easy as it gets. So this is just 1/2 u squared over 2 plus c. And if we go back in and substitute, we get the natural log of x all squared, so that's our u squared, divided by 4 plus c. The next integral is dx over 1 plus e to the x. So as written, it's not really easy to find a good u to substitute in, because if we let u, for example, be e to the x, then our du is going to be e to the x, and we don't have another e to the x in our integral. So we want to rewrite this. And so to do that, we're going to multiply by e to the minus x over e to the minus x. So we're just going to multiply by 1. And so this is going to equal e to the minus x. Okay, that's going to be on top. And then on bottom, e to the minus x times 1 is e to the minus x. And e to the minus x times e to the positive x, those are just going to kind of undo each other and go to 1. And then our dx. And now we can let u equal e to the minus x plus 1. And our du is going to be the derivative, or minus e to the minus x times dx. So we could write this as e to the minus x dx equals minus du. And now we can substitute. So this becomes the integral of 1 over u, and then e to the minus x dx will just be minus du. And so this is the integral of minus integral of 1 over u du. And this integral is just the natural log. So this will become minus, maybe I'll write it over here, minus the natural log of u plus c. And then if we plug back in, this becomes minus the natural log of, we plug in for a u, e to the minus x plus 1 plus c. But you probably don't want to leave it like this. So we can actually undo this little bit of algebra we did. So we can go back in and we can multiply by e to the x on top and bottom. If we do that, we get minus the natural log of e to the x times e to the minus x will be 1. E to the x times positive 1 will be e to the positive x. And then again, we did e to the x over e to the x. So we get e to the x on bottom. And then plus c. So here we multiplied by e to the positive x over e to the positive x. And now, again, we can use our properties of natural logs. And so this is the natural log of a quotient. And so this becomes minus the natural log. So we can separate this. I'll use maybe some brackets. Minus the natural log of the numerator, 1 plus e to the x, minus the natural log of the denominator, or e to the x, plus c. And now the natural log and the exponential, they're going to cancel each other out. So this is just going to go to x. And we're left with minus, so we'll write this other term first. This minus and minus will cancel out. And we just get x, so this is the second term, minus the first term, natural log of 1 plus e to the x, all plus c. Okay, so this term just became x when the natural log undid the exponential. So our next integral, we have the integral of inverse sine of x all squared divided by the square root of 1 minus x squared. So for this, we can use u equals sine inverse of x. And our du, you need to remember the derivatives of your inverse trig functions. This will just be 1 over square root of 1 minus x squared dx. Okay, and so now you can see everything, all the terms in our integral are going to be taken care of. So our inverse sine will just become u squared, and then dx over the square root of 1 minus x squared will become du. And so when we integrate that, it will become u cubed over 3 plus c. And when we substitute, we get sine inverse of x all cubed divided by 3 plus c. And for our last integral, we have the integral of x over x squared minus 4 all cubed. So we'll let our u equal x squared minus 4, and our du will be 2x dx. Or since we have an x dx here, I'll just solve for that. So x dx will be du divided by 2. And so we can rewrite this as the integral of 1 over u cubed, and then x dx will become du over 2. So we write this as 1/2 the integral of u to the minus 3 du, or 1/2, we need to increase our exponent, u to the minus 2nd divided by minus 2 plus c. And this will be, our u is going to come to the bottom since it's a negative exponent. And we get minus 1 over 4 since we get 2 times 2. Our u is x squared minus 4 all squared plus c. So I hope these problems helped you see how to use U-substitution, and hopefully as we went along you saw why we chose the u that we did and how the derivative of our u showed up in the integral so that it would simplify. And if you need to, go ahead and go back through and slow it down to make sure you understand all the steps. Don't forget some of your basic derivatives, and I'll see you in the next video.